Hello, this is Algebra 1B Part 2. We are in Unit 2 on Radical Expressions and Data Analysis. We're in the Data Analysis part. We're in Lesson 5, looking at frequency and histograms. So, as a teacher, one of the pieces of data I deal with on a regular basis are test scores. So let's say we have the following test scores. And I'm just going to make up some numbers here. Let's say I have a 92 and a 90, an 88 and 86 and 86, 84, 83, an 80, 76, 75, 72, 68, 65, 53, and 21. Okay. So these are our test scores in a given class on a test, and I've listed them in order. Now, in order to do a frequency table and histogram, it's not necessary to write them in order, but it helps. So if you can put them in order, it certainly makes the task easier. So we're going to create something called a frequency table. A frequency table is a way to simplify the data. So you're not just looking at a list of numbers, which can kind of cause the mind to fog and the eyes to blur and water, but we're summarizing it in a simpler form and a very visual form. So what we create something called categories or bins. Okay, and first thing I'm going to notice, my lowest score is 21 and my highest score is 92, so my bins need to cover that. Okay. And so I'm going to go with it like this. I'm going to say I'm going to go from 20. 20 to 30. 30 to 40. 40 to 50. 50 to 60. 60 to 70. 70 to 80. 80 to 90. And 90 to 100. Now notice there may be a little bit of ambiguity here in this table. The number 30, for example, appears in two categories. So I'm going to use the rule. This is where I differ from the textbook a little bit. In statistics, the general practice is to have the dividing lines between the bins be the same and simply use a round up rule. So if I have a test score of 30, it doesn't go in the lower bin, it goes in the higher bin. Okay? So that's the kind of rule. Now otherwise, in the textbook, it says 20 to 29, 30 to 39, 40 to 49, 50 to 59, 60 to 69, and so on and so forth. But the bin width is still 10, so that can be a little bit of a confusing issue. So I prefer to use it this way. Okay, and so we are going to keep our frequency going here. Frequency. Okay. And so we're going to tally each occurrence of the score. So 92 is in the 90 to 100 bin. 90 is in the 90 to 100 bin. And here's where I have that dividing line. It doesn't go in the lower one, it goes in the upper one. 88, 86, 86, 84. Whoops, I'm marking those wrong. Yes, 86. So 90 to 90, 88, 86, 86, 84, 83, going to use the tally system, 80, 76, 75, 72, 68, 65, 53, 21. Okay? And we can kind of see a little bit of a picture now. We can see, for example, that 21 score is an outlier. It doesn't seem to fit with the other data. There's a definite shape to the distribution. Okay? But more importantly, I'm going to write the number of the frequency. 1 score was here. 1 score was here. 2, 3, 6, and 2 is the frequency. So this is known as a frequency table. It gives bins or categories, and then how many times that category occurred. Note that it does mean there is some loss of data. We don't have all the original numbers in a frequency table, but it does simplify and make more discernible what's going on with the numbers. Okay? Now, another step of abstraction is to turn it into a graph. So let's do that here. So we're going to make a frequency, a histogram. A histogram, the prefix hist stands for room, like a hysterectomy is a removal of a womb. Histones are nasal cavity things. And so hist means bin or room, literally. So we're going to make an x-axis and a y-axis here. So let's do that. X-axis and the y-axis. The y-axis in a histogram is the frequency. The y-axis is the frequency. Okay. The x-axis is the bins. Now this is not a bar graph. This is a histogram, and a histogram has a scale, an x scale and a y scale. It's for numerical data only. Okay, and so we're going to put the test scores down here, test scores. Okay, and we're going to put our category labels as our scale, but our scale needs to be marked off evenly. So I'm going to start at 20. We're going to go to 30, 40, 50, 60, 70, and I'm going to run out of room. 80. That's okay, I have an eraser. 90, 100. Okay, and let's redraw the line here. All right, there we go. And test scores. Okay. And so now we're going to make a kind of a bar graph. It is like a bar graph, except there are no spaces between the bins in the bar graph. Okay, so we're going to make a bar that is 1 unit high for the 20 to 30, and the highest bar is 6. So 1, 2, 3, 4. No, that's not going to work. So I'm going to mark off every one. So 1, 2, 3, 4. 5, 6. Okay, so the first bin from 20 to 30 is 1 high. And while I'm there, the 50 to 60 bin is also 1 high. Okay, I'm going to do something for the 30 and 40 bins. The 30 and 40 bins, the frequency is 0. You might think there isn't a bar. There actually is a bar. It's just that its height is 0. Okay. And then we have 2 high for 60 to 70. And we have 2 high for 90 to 100. Okay, and we have 3 high for 70 to 80. And we have 6 high for 80 to 90. Okay, and now I'm going to put in my vertical lines. Okay, so when you make a histogram, if you're doing it by hand, make sure you use a straight edge. I would definitely use graph paper so that your markings are evenly spaced. If you don't have graph paper, you can Google free graph paper and find plenty of websites that will allow you to generate your own graph paper and print it. Okay, here we go. Boom, boom. There. Voila. All right. And you can shade it in if you like. You can label the heights of each of the bins or the bars. Okay, that is a frequency table and a histogram. Okay. Now there is something called a cumulative frequency table. Okay, and that does this. Basically, it sums up the column, the bin frequency, plus all the other ones before it. So 1 is the first cumulative frequency. Okay, then 1 plus 0 is still 1. 1 plus 0 is still 1. 1 plus 1 is 2. 2 plus 2 is 4. 4 plus 3 is 7. 7 plus 6 is 13. 13 plus 2 is 15. Okay, and you can make a histogram out of that as well. Okay, let's go ahead and do that here. I think I can manage here. I'm going to need to use my lasso tool here to grab this and move things. Okay, because we need to make it higher. Okay. All right. And frequency got cut off here. All right. Let's clean it up here. Frequency. And we're going to go all the way up to 15. So 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. And make my bar go up that high. Okay. So I'm going to do a cumulative frequency. So now the cumulative frequency histogram looks like this. It's the first bin is 1, second bin is 1, third bin is 1. Okay, then we go up to 2. And notice, by the way, with a cumulative frequency histogram, it's always either level or going up. The tallest bin will always be the one on the right. 2, and then 4, because each bin is the sum of the previous ones and the one you're on. 7, so 4 plus 3 is 7. And you can kind of look at it as we're going to add, and now we're going to add 6 to this one. 2, 3, 4, 5, 6 to get up to 13. And we're going to add 2 to this one. So the cumulative thing means we're adding all the previous ones in. And notice the shape is a little different. It's always going up. Always going up. Or staying level. It can't stay level if the next bin is 0. Okay, cumulative frequency table and cumulative frequency histogram. Okay, and you need to be able to do both. In this case, I've graphed both on the same axes. Okay. And a good example, by the way, of this is the coronavirus statistics that have been kept. They use a cumulative frequency table when they're talking about total cases. So anyway, hopefully that helps.